Hi guys, so it's Bob Grenier, a volunteer with the Martin Fleischmann Memorial Project. I had a little bit of sleep this evening, so I've woken up and since a lot of you are often in the United States, I decided to try and get some things out whilst they were fresh in my head from the Global Breakthrough Energy Movement conference that took place this weekend. So I've already had some sessions with Mats Luan regarding the first day's conference events and also the Sapphire presentation. But there's many things that maybe you want to ask potentially of what happened maybe on the second day, which I'll go into some detail now, and also some other things that happened during the weekend. Okay, so let me go through my notes. If you want to ask questions, start firing away. And I will start. Let me just go into one thing. That the very first speaker of the weekend was Uric Schauberger, and this is the grandson of Victor Schauberger, who everyone might remember as the world-famous naturalist who asked us to look at nature. And this is a man that inspired me, one of three men, including, and primarily, firstly, it was Francesco Piantelli, and then secondly, it was the comments of Kenneth Shoulders that were really suggesting, you know, to look at nature, don't tell it what it is, you know, let it show you. This is basically what Francesco Piantelli said in 2015, January, to myself and other MFMP members. And then there was the phrase by Kenneth Shoulders where he says, you know, if you don't look, you don't see, and you don't even know what you didn't find, something along those lines. I'm paraphrasing that, and that's true. So it's not like asking nature to tell you, rather than telling it what you are saying it's doing. Look to see what it is actually doing and be open to that. But also look in any way possible is the kind of message that I got from the words of Kenneth Shoulders. Many people out there have, I guess, in the past chosen not to look because they think that what they're seeing isn't possible, or that there isn't anything of interest. And I think Alexander Shishkin has summed this up when he said that people many years before were seeing what they thought was noise on X-ray emulsions, but it turns out that that may have actually been strange radiation, these kind of little birdies. And so they had missed this thing for so long because they didn't understand how those things could be there. So they just ignored it. And so it's those two people, and also Victor Schauberger, who's looking at the nature you can live and walk and breathe in. I wanted to really, over the last couple of years, wanted to look into what you see nature is doing at the micro and nano level. And try and understand more than just this is a crystal grain, these are atomic arrangements, and so on. Why are things small after an experiment taking on the form that they are? What is the processes that are making them do that? So we have a comment here saying, please describe how the self-organizing plasma construct, complete with double layers around the anode of the Sapphire project device, represents a macro scale EVA. Okay, so well, there's a lot I want to get into, but I do actually want to talk about that. There's a thing that Feynman said, which is like likes like. And so if you have a distinctly positive charge here and a distinctly positive charge here, you might think they would repel each other. But actually what happens is there's a negative kind of charge kind of organized around the positive charge here, negative charge organized around the positive charge here. And in between the two positive charges, you have more negative charge because you've got a lot of positive charge than everywhere else. So they kind of get attracted to the increased negative charge in between. So contrary to what you might think these do you know, ordinarily, they actually start pulling together until the positive charges themselves balance out the extra negative charge inside, and they kind of organize at a distance. And if you imagine you've got these in an array over a whole area, then it's the basis of self-organization. And this is what you're seeing on the tufts on the anode of the sapphire reactor. And then beyond that, you have a situation where, as you get more and more of these things, the forms of whatever they are, the arrangement of the charge clusters arranged so that they're not organizing like this, they go into a layer. And Schauberger's described this, that if you get the charge clusters in a certain way, they can actually skin a material. And effectively, once it's skinned the whole material, then the next layer out is kind of like a skin. And rather than organizing as spheres on the ball, they're now organizing as entire spheres, and they're attracted to each other, but they're also repelling each other. So there's a balancing system, and it's dependent on the potential, the electron flux, and everything that's going on with the gases in that system. So it's a self-organizing system, both at the tuft level and at the double layer level. And so you see these things all throughout nature, but actually it's quite nice to see that visually in plasma. And so, yeah, so really just go and look up the concepts likes by Feynman. So these things are out there to help you understand. So we have the question here: monopoles do not exist in nature. So yes, there's a negative in between. Yeah, fair enough. Good. Okay, so I want to carry on with my comments about Uric Schauberger. So it was really quite nice to talk about his family and stuff and so forth. But he's in Austria. He's not so far away from me, down in the southern part of Austria near the Italian border. So I hope I'll be able to catch up with him and spend some one-on-one time with him, because he seems like a really nice guy to hang out with. And he gave me some of their cards from the museum or place where they organize their conferences. There's one here, which is obviously the vortex of water kind of going down a drain type of thing. Actually, it's interesting. I don't know if anyone knows this. I was thinking this when I was looking at these kind of spiral vortices of water going down the drain. I had the pleasure when I was about 19 to go to Kenya, which actually has the equator running through it. And they do this thing where they have a bucket and you put water in it, and at the bottom of the bucket they have a little hole, and of course you can imagine the water's draining out of the bucket. And what they do in there to maximize the visual on that, they put a matchstick on there. So and it's absolutely amazing. You would not believe it, but you can walk a few meters one side of the equatorial line, and the water goes through a vortex down one way. And then you walk, a couple of tens of meters, the other side of the equatorial line, and the water goes down the other way. And when you're actually standing on the equator, it doesn't know what way to go. The matchstick just sits there, and it kind of like doesn't drain out like it does. Because those of you that know, the fastest way to empty a bottle is to put the water in, turn it upside down, and spin it, and actually trigger that vortex to go. But yeah, so that's what I see when I see that, is my experience and fortune I had to experience water going down the plug hole in Kenya on the equator. Okay, so the second speaker was quite funny actually on the first night, and I want to talk about what we. The way it was organized, the conference, they had this first evening meeting that it was quite pricey, but I thought it was valuable to go to. They had this meet the speakers dinner where if you paid extra, you could go and be with the speakers, and it was quite an interesting format. So it was kind of like a dinner, and and it was number of courses, so there's plenty of time for talking with space in between. And you were sat in random places on tables where the speakers were also situated. And the idea was that you introduced each other and learned a little bit more about them in a more informal setting, and so forth. So this was really good, and I liked the fact that it was right at the beginning of the conference. I didn't really know quite a lot of these speakers, and they definitely didn't know who I was, which is nice. So it was just like two people meeting, and you're in a situation and so forth. But it was kind of like speed dating for the interested in the interesting, because after every course, they moved the non-speakers to different tables, so they had to move around and have the next course at a different table. I really like this because it was forced mixing, and also one thing that's been a bit of a bugbear for me for the ICCF conferences is that the night before the final days of lectures or whatever, and also at the CMNS meetings, the final day before those last days of presentations, they have this immense banquet. I mean, in ASTI, it was like 7 hours long, and people were coming back slaughtered at 2, 3 in the morning, and there was presentations at 9 a.m. You know, they're not going to be on best form even if they turn up. And this way, the kind of big kind of meal was actually right at the beginning before the conference. So, you know, you actually learned and got to know people before you actually saw really what they had to say, what they had to comment. It's really, really interesting, and it meant that the people on the Sunday weren't like in a state of completely awe. Anyway, the guy that I happened to be sitting opposite, it just happened to be an English guy, and he had he set up this NUI Foundation. It's a community interest company, and he talked about it. They visited, previously he visited a couple of hundred people who had made claims, and he'd gone all over the world, and they'd all been a complete failure. And he basically had this spiritual event where he had to approach things differently. He talks about this in his lecture. And subsequent to that, which was like only in 2018, he suddenly started seeing technology that seemed to be working. It was like, how is this even possible? He changed his perception of what he should be doing, and that was interesting. But the other interesting thing was, I'd seen him before, and I'd seen him in Graz. And it turns out that he'd only ever been to the Graz conference and to this conference, and I happened to be opposite him. That was a bit weird. Anyway, the guy to the right of him, as I was looking at him, was the second speaker, and that was Theo Almeida Murphy. And you know, I was very happy to. I tend to talk a lot, and people that have been with me go, "Oh, motor mouth, whatever." But I wanted to really listen to what these people had to say. And Theo was a real water expert, and they were. He was going on about, he's a professor at a German university, he's half Spanish, half English, but that's by the by. And he was talking all about different types of water technologies and so on. And he got onto HHO, and he was talking about this and the Mars gas, and I let him talk himself through. And then I said, oh yeah, we've had some experience. We went and visited some testing and did some testing with a Mars gas. And he obviously hadn't noticed. Anyway, the point was is when it came to his presentation, he was going through and he was saying, yeah, we tested an HHO generator from a number of different people, and we're seeing temperatures of around about 130 degrees for the gas on its own, but it can do some really weird things with metals and something along those lines. And then he started throwing up pictures taken from the end of the beginning presentation, the 90 minutes of testing that we did in the last day with Dr. Roy Shinamaza. And, you know, it was really funny to have no idea that he knew me and I didn't really know him. And he's putting these slides up from this work that was enabled by, you know, the community and so forth earlier this year. And there it is. It's right up there. Of course, at one point he made an error when he was referring to something as Teflon, and it was actually titanium, and it was not a Mars gas alone at that time. It's 10% propane and a Mars gas, and it was the highest temperature recorded on the day, which is well over 900 degrees, but it doesn't melt the titanium because it's actually got the carbon in there. So, but anyway, I had to step in. I couldn't let that stand. So I had to say, sorry, got to correct you. That isn't, it's not Teflon at that point. That's propane mix. But anyway, so anyway, we had some good chats as well, and we're going to connect together in the future as well. So, but for me, the really, really huge win of that night, and if there is a spiritual journey here, then the third person I sat opposite was also not a speaker, but he was a guy there, and for the moment he wants to stay discreet about who he is at this stage. But anyway, he said that he interacted and spent quite a bit of time with Yul Brown. He was talking about his different research projects, and if I spelled them all out, then you would probably be able to work out who it was. So let's just keep it at that he had various types of research projects. But then he was closing out by saying, and then I had a good relationship with Yul Brown, and I bought 2 of his gas generators. One happened to disappear through a sequence of events, and he has one. It cost $10,000, I believe, in the 1990s. And he was describing how Yul Brown, after he did those tests where he demonstrated almost immediate remediation of americium-241 and cobalt-60, he then went on to, and that really didn't get any traction, even though there were senators there and watching it, and that was disappointing. But he ended up going to Mongolia, and it's almost unbelievable what the guy was saying, but maybe it's true. He said that the Chinese and Mongolian governments, they gave him 10,000 employees, 10,000, to research and to build a factory and make these things en masse. Now, this is on Rex Research that this happened, but to actually hear it from someone who knows the guy whilst he was alive, that's absolutely astounding. And they made a lot of these Brown's gas generators. And the story that he was saying is that Yul Brown said, look, I don't mind you all having this technology and being able to use it and stuff, but I just want 100 units. This is my give back. I want 100 units that I can go and sell into the West. And essentially that happened. I don't know whether actually 100 was sold, but this unit is, to the best of my knowledge, the only one that is there. And so I said, and he says, I'm not really doing anything with it. And I said, well, maybe we can help each other because X, Y, and Z. There are some similarities. Gas does have its own special characteristics, but a lot of people have tried to emulate Yul Brown technology. But what happened was there was the technology he did that's in his patents. And then these devices were the end of the research of Yul Brown. They're the final product that ever existed before he passed on. And we are going to have one. And so I want to do a Kickstarter because there's money to, and this will be after I've finished the publication of the Alexander Parkhomov A Space Earth Human book, which is closing out now. But we have to go and pack it up. We have to ship it across many state lines. And we need to break it down, clean it, build a new transformer for it. But what I actually want to do, and this is my vision for this, is to absolutely, completely reverse engineer this device. And that would include producing SolidWorks drawings for all the folded metals, so these can be contracted out by any party that wants to make these things, actually analyzing exactly what the metals are used in the conductors, in the electrolysis plates and everything. And so, we have an opportunity here to exactly be able to publish an open source, something where the patent has gone, there's no protection on it, and make that available to the worldwide community as a starting point from where the end of Yul Brown's research. So this is really exciting. And it also means that we can test it on various metals and then actually look at what was never published or understood to be published on tests on various metals by Yul Brown, actually to test it on, say, tungsten, and to see what's going on on the if there's any atomic shifts and so forth that we observed with the Mars gas. So, you know, this is a really incredible opportunity. It's just amazing that absolutely no expectation, no idea that this would occur, and before even that meal was out, we were given as an organization the opportunity to bring one of the most mysterious technologies into the open sphere completely, with the end of the research of the original inventor. This means for this technology particularly, it will not be a lost invention, and you can have a part in playing making sure that that is not a lost invention, and that we can advance as a society from the understanding of that invention. Okay, so I'm going to pause right there, and I'm going to read some of the questions. If there's questions or comment, I don't know. So okay, hello Blues Doctor, hello my account, whoever you are, DKTZ. Yes, of course, the repulsing. Actually, Uric Schauberger did discuss the repulsing, and he also discussed the documentary where they went out and they found it. And guess whose lab it was in? Hal Putoff's. Anyway, they span it up, but they didn't want to spin it up too fast because it was the only one existed. It's also a historical artifact, so it might have fallen apart. So anyway, yeah, the repulsing, and he did talk about that. So okay, the Book of Pollack. Yes, I'm looking forward. Thank you, Kabina, for putting me on to Pollack. I'm looking forward to seeing what he has to say. I've seen a couple of presentations of him. His in the past. Electrons and clustering are the core of this phenomena. Kabina, yes, I agree, and also electron interactions. And so forth. Coriolis effect, yes. Do you mean Coriolis effect in the sun, or do you mean Coriolis effect in the mantle in the earth? Effect right in the equator. Yes, yeah. Okay, so I get what you're pointing. Yeah, it's one of those things that I don't think anyone gets taught at school, and it's only by sheer virtue of being on an equator and being on a trip and someone wanting to show this phenomena, you know, that you understand that and for me it's quite striking, the fact that on the equator it can be such a sudden change. It's like you've literally flipped. You flip state. Up to that point it's all going down the drain one way. Going down the drain one way, it kind of literally goes boop, and goes down the drain the other way. It's just crazy to think about that. Okay, so I wish I could have been at this conference. Where is it this year in Sweden? I don't know where, you know, they had a gap for a couple of years. So I actually spoke to some of the organizers, and, you know, they've got back motivated. I think this was a really good conference for them. You can get a streaming license and see the stream. I know the recording of the events and the Q&As and the panel sessions. It was a little awkward, actually. That's one of the format I didn't totally appreciate, because at the end of each presentation it just went straight on to the next presentation. Well, that was great. That kept the timing of the day. So from that point of view, well, mostly, didn't always, but it kept the timing of the day. But it meant that a lot of people had questions to ask, and you know, by the end of the day, after the panel session, they'd forgotten them. Fortunately, I kind of clocked this, so I used my tablet here to record many questions. In fact, probably for every speaker I had about 20 questions, and really, given the fact there was only an hour set aside for questions for the whole day, it was a course of like, which speaker do I ask a question to, and then maybe you get to ask a question. I think I had a good fair shake of questions. So, and if you go and listen to the streams that are there, you will see the questions I ask, and they're pretty straight, serious questions. Anyway, so yeah, so from that point of view, the fact that it's streamed is great, but I can tell you that it's not the presentations really that are the important thing about a conference like this. It's not the even the Q&A. It's the downtime. It's the time at the meals, the dinners, in the coffee breaks, as you're walking around the hotel. These are the times that are really important. Most of the really important information that I learned in Sochi, for instance, and in fact most conferences, is in those kind of one-on-one, one-on-two sessions where you're sharing information that maybe is a little bit more raw, or you know, it's something that you're not necessarily happy to put into a presentation, but then you know, other people have seen the same thing, and but they're not ready to say it, and so you learn these kind of things. It's just not, they're never going to be seen on the presentation. So I recommend that if you can in any way get to these kind of conferences, and then be fairly focused, because there's little time for both the people you want to speak to and for yourself outside of the presentations. Certainly for me, it's completely exhausting, these things. But that's where the big win is. So if you get a chance to go, I suggest you do. Cabana, the basic self-organizing principle of the nanoscale EVOs, a macro scale world, the microscale EVOs produced for shoulders utilize the same principles and produce the same. Yeah, I mean, it's all the same, it's just different scales. And yeah, you do need ions in there to stabilize it. And so the shoulders describe this well. But you know, when things are unstabilized, they are because they become they come next to an impedance change. But if you're able to build the EVO, so Shoulders actually had a thing called a penning trap calculator. It's a piece of software, and he could trap his devices in this little cradle where you have a capacitive gradient and a magnetic field gradient. So I've talked about the fact you can't store these things physically if you want longevity of your reactor, and this is how you do it. You do it through fields that they can respond to, and they respond to them as long as you keep them. Shoulders said you need to feed it with electrons, because if you don't get it fed with electrons, then it can start to wander. And it likes to shed the electrons, so you need to feed it matter, and you need to feed it electrons to keep it alive. Okay, so it's okay, right. Okay, so there's a discussion going on. This is great. You're right. There are dozens of teams working on altered forms of water. Yeah, I was talking about how these things, EVOs like to store themselves in metals, but they also like to store themselves in ions. In part, I've described in detail that how I understand that the echo reactor is able to run stably for a long period of time is these actually flowing right the way through the metal parts that are closest to the ceramic core reactors, which are fairly open. Those metal parts have all got ion-rich tap water flowing through them, and that one way you can decontaminate, say, Hutchison samples or anything that's exposed to this technology is to pass iron-rich water over or through it or near it, and the ions in the water will take away the EVOs, and so, you know, if you actually wanted to create water that's special, you could have these exotic vacuum objects in there, and to a certain degree, I described how to some people at the conference how Roisin Amaza actually has facial sprays, drinking water, and I've actually shown on a previous live stream where he had the official Rugby World Cup, or one of the official Rugby World Cup's energy drinks, and these are produced by the vibration plates, which we know are creating high ultrasonics now, and which we know that creates the cavitation, which we know can do transmutation, but it can also create EVOs. And because we know there's ions in the water, it's going to have EVO-rich water. And there's things like Grander water, and Grander water has this kind of energetic field, and the EVOs themselves, as is my understanding, can harvest energy in the form of any form of phonons rather. So, sorry, any form of bosons rather. Now, I discussed this in my Sochi presentation. So, examples of bosons would be actual nuclear bosons. So, like a nucleus of a helium atom, or a deuterium atom, or a carbon-12. These are all bosons, even the calcium-40. So they're all bosons because they've got integer spin. And anyway, so that's what they can be fed with. But there are other bosons you can feed them with, like photons, and this is I talked about the fact that Baranov and Zertalep in their bismuth alloy impact, where they created strange radiation from these bullets that they fired at 1,000 meters a second out of a rifle into a metal target, produced strange radiation. They said that 2 years afterwards, they exposed that metal to sunlight and it started producing strange radiation again. So in my view, that is harvesting the bosons in the form of photons, and that is actually re-stimulating and energizing the EVOs that are trapped indefinitely, according to Shoulders, in the metal, and that is able to then start producing these, if it's strange radiation, it would be string vortex solitons in the form of condensed low-energy neutrinos. So anyway, the point being is that you can reactivate this material with sound, which is bosons, phonons, which are bosons, so that's any form of vibration, light, and actual atoms that are out of bosons. So if you can get it in there, it'll take it on, and it makes and constructs and reorganizes. So the grander water that's sitting there is able to not only capture thermal energy from the environment and keep itself active, it's able to stimulate the environment around it up to an area, and so you don't get calcification of pipes, and you don't when you put it into, say, a pile of chicken dung, the bacteria are highly activated by this stimulation that comes from effectively tapping the chi field, and so the bacteria work a lot faster, so you don't have like hard poo, you have a slurry which is easy to clean out and so forth. So I urge everyone to look up the scale of physics. Okay. So I'm just reading through your comments. If you actually have questions, then please put them there. If you want to do a 99-cent super chat, that helps fund our website maintenance. We only get 75% of it, but it helps. 70%, I think. Not only a linear, yeah. Okay. So this is boring for the people that happen to skip to this point. I'm just looking through the questions. Okay, so I think I have a question here. Wait. Bob, what gas combinations do you think have been tested by Sapphire Project in their system? Are they utilizing principles of having both lighter and heavier elements aka noble gases? So I'm sure there are. If you look at their videos, they go around in their experiment and they show that they have various gas tanks. Actually, they had this whole thing where they did this, showed how they have a spectral analyzer to look at any elements that might be in there by looking at the light and so forth. At one point, they let it slip in the Q&A, I think, that they were seeing helium in there. Whether they were putting helium in there, it doesn't, why would you say you're seeing helium if you didn't put it in there to begin with? That's one interesting thing. But there's this thing about manganese 55, which is monoisotopic, and they said that this is something that they're definitely seeing. And I actually did some, on the Parkhomov reaction calculator here. Well, they've got a steel anode in the middle. That is where the manganese that they know is not there is reappearing. If it's steel, you would imagine that it is, and chrome, at least to a certain degree. And if you look at the reactions, and I put the possibility here to have deuterons, and maybe you can't see that, deuterons or protons in there, and iron, and then the outcome products from that, from a basic 2-to-2 reaction, yields chrome, which you can't exclude because it may have been in the steel to begin with, iron, which it might have been in there to begin with, and the only other elements that are synthesized are helium, and manganese. Additionally, for the deuterons, there's also hydrogen. And at one point, they said they were creating a lot of hydrogen. Now, why would you say that? Well, because that's what happens. And we already know from Piantelli that Lena reactions can eject a proton in the form of a hydrogen nuclei, obviously. So what you observe is if you put a deuterium in there, you will get manganese. And there are several reaction pathways that do that. And if you put hydrogen in there on its own, in fact, you can start with iron 58 and protium, and you get helium 4 and manganese 55. So it doesn't actually matter whether you have hydrogen or deuterium with a chrome and iron. Well, just even with just an iron, pure iron anode, you are going to get the production of manganese. So this seems fairly trivial. If you do a slightly more advanced cascade reaction with hydrogen, deuterium, all the chrome isotopes and all the iron isotopes, the products that it generates, and if you actually look at the history on the nanosoft.co.nz website, you will actually see the queries that I've run, and you can go and look at the tables. And if you look at the thing that I've just described, where you've got hydrogen, deuterium, chromium, and iron, you will see there that all the elements that they see, it says, what you will see is hydrogen, deuterium, tritium. There was a mention of seeing mass 3 in their previous review video. Then helium, then lithium. They mentioned in their presentation they saw a lot of lithium, silicon, sulfur, calcium, titanium, and zinc down there. So the elements that they see are synthesized by just a few steps in a cascade reaction sense. You can see them here. And like I say, if you go to nanosoft.co.nz, you can see. So actually, to give I did speak at the end of the Q&A about sorry, it was the end of the day. I asked a question after their presentation because they had a little space to do so, and I talked about the risk of string vortex solitons, strange radiation, and so forth. And that given the fact that Parkhomov's reaction tables and our calculator predict the observables that they observed in their experiments, and that what they have in their experiment is an anode that has decayed in the same way that's very well described by the presentations in fusion technology between 1990 and 1994 by Takaaki Matsumoto, and that Takaaki Matsumoto saw the same marks that you get from the string vortex solitons and from EVOs, and in 2002 actually conceded that he had replicated EVOs. All of the things there are, and also that he observed the same kind of synthesized elements that they seem to observe in the sapphire reactor. And I said this to them. I said, you know, basically you are witnessing the same process, and therefore you need to concern yourself with that it may be producing, almost certainly will be producing, this form of radiation which you will not be able to detect with normal detectors. And that given we now have Rossi suffered, and we know that Matsumoto died from cancer, we know that Shoulders died from cancer, we know that Norris Peary died from cancer, we know that Yuji Bajatov died from cancer. You are going to get this coming out of your system, and you need to have detectors. So I said I'd like to reach out to them about detection and protection. And to give him his credit, Michael Claridge immediately came up to me after the presentation. We started speaking, and then we went had lunch together, and I shared a lot of details with him. And later, Montgomery Childs, in the question and answer session at the end of the day, I posed some things that they probably need to think about and so forth. And so they said that they will be happy to talk further. So I hope that does come to fruition. If they're listening to this and they can't find the time to speak to me, then please look at some of the videos that we will be putting out there. And please take the time to look at the Space Earth Human, because it describes the whole process of the tale of discovery of this type of radiation, how it was proven to exist and what it can do, and so forth, at least at the, you know, the remediation of nuclear waste, so that you can understand the A, B, C, D steps of it. So yeah, that was very good. So that was so they have all the gases there, I guess, and they can put what they like in it. But certainly from what they've shown that they've observed, they only really need to have the hydrogen and deuterium and maybe helium or whatever. Or nitrogen, fairly standard gases, and a few noble gases. And noble gases, like if they have xenon in there, it's a really heavy nuclei, extremely easy to ionize. The most easy, well, radon would be easier, but it's radioactive. So xenon would be the gas you wanted in there. You can ionize that really easily, and it's highly massive nuclei, and that will be very good for stabilizing exotic vacuum objects. So yeah, so I imagine that they will have xenon in there, and then of course xenon presents potential fission or nucleon exchange reactions quite readily. So you would have a synthesis of large numbers of lighter nuclei. But the main reaction, it's interesting that they will see something in the gas. Of course, and of course the EVOs are condensing things in themselves to extremely high densities, as you saw from some of the papers, some things that I've discussed, and also some of the things that were discussed from ICCF 22, excuse me, ICCF 22. But where the real action will occur is on the condensed matter in the form of the anode, because according to Alexander Parkhomov, it's 7 orders of magnitude more likely for the electrons to interact in such a way that they synthesize the cold neutrinos. So that's where most of the action will occur, and so that's when it'll trigger nucleon exchange reactions, fusion, fission, and so forth. So an eating of the nuclei in there and converting it into whatever, with some balancing, and maybe there's some net energy, and it would seem there was, and that's where most of this will occur, right on the metal. And so let's moving on. Yeah, about the nature of a Mars gas. A Mars gas has water clusters. It has a percentage of how would you put it? Atomic hydrogen. It also has some carbon dioxide, and this is interesting actually, because Tio Almeida Murphy, he was saying that they observed quite a lot of carbon dioxide and quite a lot of oxygen in their reaction. I actually did a reaction for his data as well on the reaction tables, and if I pull it out, I think it's here somewhere. Maybe I have it here. Anyway, the net result was he was seeing this carbon dioxide, and he was seeing something else. Anyway, some argon. And if you start with standard water, hydrogen, oxygen, and you're doing your electrolysis, you can do the most common isotope of hydrogen is protium, H1, and the most common isotope of oxygen is 16. These two come together and they form oxygen 17. 2 oxygen 17s can fuse to form neon 20, whatever it is, 22, and something else. I think a helium atom comes out. Or you can look at the reaction, and the neon 22 fuses with another oxygen 62 to form the argon. So the most likely first reaction, given the fact that nearly all of the water is protium and oxygen 16, yields the oxygen 17. The next reaction from the first most likely reaction is the 2 oxygen 17s go to at least yield this whatever it is, the secondary reaction, and then that goes on to make the argon. So it makes the carbon. So that's right. The oxygen 17 makes 2 carbon. Oh, I don't know. Let me look it up. I actually, if I go back to the history, I might be able to find it. So I'm going to look at where is it? I haven't got data here on my tablet here, so okay, I'll get back to you on that. But anyway, the observables of Almeida were the ABC reaction that's most likely. So that was very interesting. Okay, so yeah, it can be effectively burnable water. It implodes. It does implosion. Actually, it was the guy that has the Brown gas generator, and he said that Yul Brown did these tests where he took a bell jar and he filled it up with water, but left and turned it upside down in a bucket. He put a bit of Brown's gas into it, so it had a little bit of Brown's gas in the top. He lifted the bell jar up, so it's kind of like the water's pulling down, the Brown's gas is right at the top, and then he put in some sort of trigger right the way into the Brown's gas and exploded it, and the water went all the way up to the top of the vessel. So basically, it was completely imploding. I thought that was quite I hadn't heard that description before. Maybe those that are more into that had seen it before, but I thought that was quite interesting. Yeah, I think the cavitating paddles make a huge difference to a Mars gas. So Dutch Sense says researchers have turned metal into plasma under high pressures. Yes, I guess. Cavitation can produce EVOs due to charge separation. Yes, of course, that's how Shoulders describes it. I mean, when you think about it, you've got the charge separation. At the very least, you're going to have a very small amount of gas of the water in the center of the bubble at extremely low pressure. And then we all know that when the bubble collapses, you get these bright points of light. But and if it's on a surface, it's got a spiral. So you've got all the kind of things that you might need to create an EVO, like with high charge separations and potentially discharges and intense pulses of light and temperature and so forth. Okay, so Bob, would you agree that one method of preventing the destruction of devices in the production of thermal energy is to tune the system to resonance so the EVO detaches from the electrode? Anyway, anything that can get the EVO off the electrode and keep it not touching anything metallic is going to prevent destruction, because the EVO itself can live in free air, but it needs to have the ions within it to keep it stable and make it stable, and then give it some fuel to live. But you're going to need to be in an environment where you can charge pump it with electrons, and you're going to need to be in an environment where you can give it access to a gas to work with, so that it can grab ions in. But really, it's going to go to town when it's working with metals. It's going to eat up those conduction level electrons and start absorbing the ions that are then thus produced left over, and it's just eats itself, and they all go into the material, into the EVO. The literature states that a complex base charge configuration will appear on the electrode and you start detaching. Yeah. Earthquake unrest. When you have any, so Shoulders describes how these exotic vacuum objects are literally completely ubiquitous, and the place where you find them are from your fingers even. But Russians have actually recorded these things coming from the cosmos, and of course there we go. So they're everywhere. I've described how up in Hessdalen in Norway, you have this large area with quartz and copper and so forth, and the quartz with the freeze thaw, for instance, in the summer and the winter, and even temperatures during the day, but also that will store piezoelectricity in there, and then you can get discharges, and this is exactly how you create EVOs. If you get enough build up and you get it from one zone of higher charge to an area of lower charge, some sort of discharge, then you can have self-production of EVOs. And often these electric phenomena are observed when you have sort of slip planes where you have earthquakes forming. When the material has a certain saturation of EVOs in there, then it can cause it to be more slippy. And this was the whole point about, Tom Bearden saying that the Duga arrays in Russia, these 111 meter high extra low frequency arrays, the one that was 4 kilometers from Chernobyl, and according to Tom Bearden is the real reason Chernobyl blew its top. These can actually charge pump the EVOs that are naturally stored in the metals in the rock, and then you can trigger them to slip and create earthquakes. So I have a specific name for this whole technology that I'll talk about at some point, but it's a little bit frightening when you know you can make something hot and you know you can make something cold, and it's the same thing you do to both, and what goes up must come down. In time, these things will be very, very clear, but you can trigger earthquakes with these things, and that is. But when an earthquake does actually go and the EVOs do dishevel, then there's some disruption in terms of the space charge around the earthquake zone. So you get these kind of like glowing lights and stuff. So these things are all related, and it helps people to understand that the EVOs are a ubiquitous phenomena, and also that they can scale to any scale. And when yesterday or whatever it was the day before, I suggested that you could go ahead and structure an EVO in free space. Effectively, the beauty of free space is it's like that penny trap in a Shoulders reactor. It's like space where the EVO you can charge pump it, you can feed it matter, you can get it to suck and organize matter from the ether. But it doesn't have any impedance mismatch, so it's not going to be destabilized by that. So you can grow it and grow it and grow it and grow it, and it's only when you deliberately destabilize it that you spray down your solar system or you spray down your galaxy. This is how shall I put it? In 2017, I said make and break. This is it. You can make anything, and you can break anything with this. And the meek shall inherit the earth. Specifically, when I say the meek shall inherit the earth, I mean the phrase as it should be said. And that is that the translation from the original text was misinterpreted. It's not meek like I will do what the government says for me, and I'll pay my taxes, and I won't want too much. The actual text is from what was supposed to be actually said, correctly translated, is those that know that they have great power but choose not to use it, meek, will inherit the earth. Those that know they have great power but choose not to use it will inherit the earth. The meek shall inherit the earth. This tool is beyond anything you can possibly ever imagine. So moving on. Would EVOs cause nasty fission products to effectively become stable packed nuclear? Okay, so if you look at the introduction to the Kickstarter, the introduction video I did to Kickstarter, you can look at it on the MFMP's channel. It's only 5 minutes long with a core message in the first 180 seconds. In the first 180 seconds, I have a couple of historical papers with QR codes, and you can use those QR codes to go and read those papers. And in one of those papers, it describes how with neutrino physics, you can't have a radioactive product. It doesn't matter whether you put radioactive elements in or whether you put stable elements in, you will only get stable elements out. Where this breaks down, and I was trying to educate as many people as I could at the conference, particularly those that are starting to see transmutation or getting working technologies, is that if you push it too hard, like in the case of Adamenko, when he did these 300 joule discharges at relativistic discharges through a hydrogen atmosphere into a metal target, and he was seeing every element in the periodic table, plus a lot of elements that were not in the periodic table, outside, not even in our near universe, but also all the transuranics and radioactive particles as well. And also the same with Claire, because he was driving the cavitation too hard. What you will get is like a big version of what was observed by Piantelli and Focardi in their most energetic reaction. And in that specific case, this is a microcosm. So the reaction byproducts, as I said, they're getting a lot of protium or atomic hydrogens being synthesized in the sapphire reactor. Well, that's because many of the reactions produce a proton as one of the byproducts in order to make a positive net energy yield. And because the particles, let's say it's got 7 mega electron volts, and you've got one chunk here which is a big nucleon, and this one's a proton, they actually separate kinetically. The energy that 7 mega electron volts is distributed between the two parts of the fission or of the 2-to-2 reaction, and this one flies off. And the proton, in the case of Piantelli and Focardi, interacted with vanadium-50 in the stainless steel in their reactor, and that caused a standard particle physics reaction that then yielded a neutron and meant that they couldn't go into their lab for 3 weeks until the nuclear authority said it was safe to go back in. And that was the rod that he eventually got back after 3 weeks, put into the cloud chamber, and worked out that the protons were coming out and yielding an energy of 6.7 MeV, which could do nuclear reactions, and was the basis for his patent for his aneutronic processes. Okay, because you're interacting with lithium-7 to beryllium-8 going to helium 2,4 helium, or with boron-11 going to carbon-12, again a neutronic. So he got round the problem of destroying the reactors by subtly doing this. You need to be gentle. The meek shall inherit the earth. You need to be gentle with this process. If you do what Leclerc did, if you do what Adamenko did, you produce these super heavy nuclei, and the supernuclei then collapse as the EVO collapses, and it sprays out alpha particles that are extremely high energy, and they go and interact with other nuclei, and they form radioactive isotopes, which then decay. So this is why you cannot, this is not a technology that you want to go, I want to make it bigger. I'm going to make one that produces a COP of 20. Let's say you have a COP of 10, and then you gang that to 10 reactors that have a COP of 10. You then got, 100 plus, right? But if you want to get the first reactor to do a COP of 100, you're going to kill people. You understand? You can't push this too hard. It'll destroy the reactor, and it'll also do things that you just don't want it to do. So it's not the primary Lena reaction. The primary Lena reaction, we can go out there and we can fix radioactive materials like Yul Brown demonstrated, and I'm hoping to see how should we put this? In the next couple of weeks, you may find out that tests have been conducted which show that there is a solution to the Fukushima 1.2 million tons of tritium-laced water. Let's put it like that. But anyway, what I can say is that these technologies can fix radioactive waste, and they can produce energy without producing radioactive waste. But if you push it to the nth degree, because you want to be one better than the next guy, your reactor's a little bit better, then you're going to cause yourself problems. So that's all I will say there. I was talking about the star and a jar thing with sonic cavitation and sonoluminescence. Yeah, well, so sonic luminescence is all related phenomena. Ball lightning is a form of EVO. Yes, it is. Hi, Bob. Could you go more into detail about black EVOs, how they are formed compared to white EVOs, or how they switch from one state to the other? Okay, so this is my best understanding right now of what a white and black EVO is. In the papers that I shared for the Sun, Space, Earth, Human, I talk. It may not be in those, and if I haven't shared it in there, then I will do. But there is a reaction where you have a neutrino and an electron, and an electron and a neutrino on both sides of the equations. And the electron can share energy with the neutrino, so that on both sides of the equation you have an electron and a neutrino, but there's an energy interchange between them. So if you understand that concept, you can start to understand what I wanted to publish for a long time, which is the complete life cycle of EVOs. But anyway, if you then add in Alexander Parkhomov's understanding that when you have two electrons coming together, boom, they can actually synthesize neutrinos of the low energy type, which actually have mass. So you can have a situation where you create your EVO, it's got trillions and trillions of electrons. As it pinches down like a ring plasma pinch on itself, the localized energy density goes up. Therefore, the normalized bell curve of the distributions of energy of the individual electrons goes up. They're effectively a dense condensed electrons, extremely high temperature distribution. There's at least a point in there which they're very high. They're coming together. They're vastly exceeding the temperature of 1000 degrees, which is the temperature at which Alexander Parkhomov says it would synthesize these cold or low energy neutrinos. And so there is actually mass effectively lost in the formation of these cold neutrinos, which can then ostensibly be bashed around and interact and still form this soliton. And the electrons, as we know, are energy is also lost from an EVO in the form of UV and soft X-rays, but it's also lost in the form of electrons themselves. And in fact, this is the one way that Schauberger says you can use EVOs, is you pass them down like a traveling wave tube, like you have for amplifying microwave signals, and they shed the electrons. The electrons go and stimulate the production of the cascade electrons knocked off from the tube, and that you can harness that electricity. And then, you know, the EVO will get its electrons back at some point, but it doesn't matter. You've captured the energy and can do work with that. But the EVO itself is losing these electrons. And in fact, Schauberger describes very clearly, if you go back to the 2010 interview, he can change the charge of an EVO 100 billion to 1, i.e. from 100 billion minus charge down to the charge of -1, but it's still carrying the ions. And if you look at the string vortex soliton work by Alexander Shishkin, which I published and translated from my time in Sochi last year, he's saying that they're basically the same thing, except it's shed all of the electrons, and you've just got this condensed form of these neutrinos, these mass-bearing neutrinos, but somehow they are shielding the mass and inertia. And because they got no charge, they're able to travel through metals, through plastics, or whatever. And when they get into photographic plates, for whatever, it's got silver iodide on there or whatever it is, the photographic emulsion, they interact, they dishevel, and they spit out the ions of whatever the gases that they've traveled through and captured those ions. So if you can imagine that the other part of the life cycle is if the EVO goes then as a dark EVO, that's a dark EVO. It's not emitting photons anymore because it can't. It's gone past that already. So you're not seeing the white light, the bright light, and in fact, something might be bright not because it's emitting that frequency, it's because it's emitting UV and soft X-rays. That's hitting the gas around it, and that's causing a broad distribution of light frequencies to be emitted. So you get something that looks hot, but it's not hot like the metals do. And so when it goes into a metal and it goes there, you can then use any form of boson, principally sound or photons, to stimulate that back into a state of excitation. Then it becomes a white EVO again, and it can start interacting more with the matter that it's in, and then start destroying it, like you see in the Hutchison sample. So yeah, so Peter, I hope that helps you with understanding what a black EVO is. A black EVO it still somehow is managing to shield the nucleons that it's carrying within it. This is something, so you can still do the teleportation of the material. It can go through this brick wall. It can go through my head and suddenly become excited by the ions that are charged in my neurons, and then start doing all kinds of stuff. And if you look at some of the papers published by Dr. George Eagley, people who have been touched by ball lightning, they have a tingling inside their body, and that would be, in my view, the dark evos re-energizing themselves and doing, you know, sending out electrical beta particles and so forth, as they're absorbing a bit of matter. So okay, squirrels and raccoons are the meek, and who shall inherit the earth, according to Richard Feynman. Well, Richard Feynman's got a lot to answer for with PAP. I will talk about the mistakes he made, why he made them, and the observations that he made that people don't talk about, and why it's all the same thing. After we destroy the planet with the bombs or pollution, yeah, the planet's still going to be here. Don't worry about that. Okay, yeah, let's keep it safe. Okay, did it drop off for you at the moment? Okay, if this does drop off for anyone, I am actually simultaneously recording it as a audio file, he says. I'm just checking I am. Yeah, I'm still recording it as an audio file, so I'll put it up on SoundCloud. So how do you propose we bring this to market to help more people with clean and abundant energy? Okay, so there was a French guy at the conference. I guess I can say this because it's a couple of steps removed. There was Jean Veniste, I think his name is, who discovered the memory of water. Then the guy that discovered that you could he discovered the AIDS virus, won the Nobel Prize for it. And he also discovered that you can record the transmitted signal from the AIDS virus into an electromagnetic capture that electromagnetic frequency and record it, and then send that over to another lab, say in Italy, which they have an association with, and they could reconstruct the AIDS virus using the polymerase chain reaction or whatever, where you don't actually have normally if you take some DNA from you, they need quite a bit of DNA to get those bands that you see to see that your relatives the same genes as you, or you've got cancer or whatever. What they do is they don't put any DNA in there to duplicate, but they still have the precursors for DNA in the material, in the fluid or whatever it is, but they play them the signal that they've recorded from the AIDS virus, and it reconstructs essentially the AIDS virus. So he's been working a little bit on that, but they also worked on this Mizuno type replication. It does worry me, and so we had quite a few discussions about that, because it's quite similar COP around about 1020 that is in the Parkhomov and Bajatov patent, where they're doing the discharge on the water, a little bit like I think the Mondiani experiments. In those kind of experiments, you do get a lot of strange radiation. So we've kind of agreed to either he's going to come to me or I'm going to go to his location, which he doesn't want to disclose yet because he's French, and the French are a little bit funny about their radiation. And I know of several instances where he's making the right decision to approach things in that way. Let's put it like that. So he wants to be able to sell the power. Like, I've got a load of solar panels, just really very efficient. Can I sell you my power? And be able to potentially do it like that. So it's safe for the end consumer, but I would like to make sure that they're not putting workers at risk in the generation facility. So I think it would be good for them to learn how to make the parabolic dish detectors, the Parkhomov style, use webcams, use films, and use like the boron 10 devices of Alexander Shishkin, and so that they have a selection to understand what the risk is, and also to think about shielding for the reactors, and also not to waste this power. So one thing that I was telling people the other day is that the strange radiation comes out, And I wanted to say this for a very long time. In 2012, I said to the fellow MFMP directors, I said, look, I'm in Kerala. I live on the largest chunk of monazite there is. In one of the largest, but certainly the highest local density of local radiation that a population is exposed to because of all the thorium and so on, but all the lanthanides in the soil underneath my feet. I said, I can just get lots of lumps of rock, which are basically chunks of monazite, and we get a reactor and we put it in. And the hilarious thing is, it's exactly right, because if you look at that recording that I made of Zatalepin telling Parkhomov, Sasha, you're wasting your strange radiation in your calorimeter because you've got a metal outside and it's just going out into the free air. Yeah, you kind of want to insert your reactor into material that you can kind of stabilize, and in the stabilizing process, you may be yielding a lot more excess heat. And at the worst case scenario, you're just stopping the radiation coming out, because if you've got your lanthanides in there, you're going to hopefully have a proportion of gadolinium, and there's nothing better at stopping this stuff than gadolinium. So that's one point. I want to help the Sapphire team and this team, and I want to work on the other side of the equation. I think we may have found a solution to fixing the Fukushima water. I want to fix the solids on the ground. There's many millions of tons of ground scrapings that are in bags and all over Fukushima Daiichi, and obviously there's similar problems at Chernobyl and Inupiaq Atoll, and maybe even at 3 Mile Island. I don't know, but there will be other sites that have this problem, and if you can fix the ground problem, then the last one, which I want to fix and I have a potential solution for, and I really want to see if I can focus on that next year, is to fix the cause of Fukushima. And we know that strange radiation is able to stabilize matter at a distance. I may have said this or not, but there was a time when a radioactive source supplier sent some samples to John Hutchison and said, look, can you treat this to see if it'll change the activity of the sample? And said, yeah, sure. So he did the treatment, and then he sent it back to the source supplier, and that was fine, and there was nothing. And then like a couple of weeks or couple of months later, the source supplier phoned him up and said, look, I don't want any more samples back. He says, why? I said, well, the activity of the samples that I have in my stockroom has now massively dropped. So the idea for me is I would like to work with Suhas Ralkar and to produce and test with the technology of Shishkin and Parkhomov the strange radiation output from synthesized eco fuel, and to then mass produce that in pellets to be able to literally just bulldoze into the melted down cores of Fukushima and let the solitons do their magic. Because I don't want to think that I could pass away and it's still another 1,000 generations that have to deal with that problem of those melted cores in Fukushima. I want to get to a situation where we can use the completely carbon-free aluminium fuel cycle. We can swap out in a car and put another 3 months supply of aluminium into the car, and you just put water in, and the water reacts to produce aluminium oxide, and you get hydrogen yielding. Hydrogen interacts with the oxygen from the air, making water out of the exhaust. You have aluminium oxide that you pull out. You send that off to use the nuclear energy, however that is. Maybe fission to start with, but maybe down the line when you understand fission more from to be low energy nuclear reactions. You then electrolyze that to make your aluminium, and your oxygen goes back into the atmosphere. So you don't lose any oxygen from the atmosphere, Oxygen is the most abundant element in the Earth's crust. Aluminium is the third most abundant element in the Earth's crust. We're not going to run out of them, and we don't run out of them because every single bit that we use, we recycle. The only thing we're doing is getting electrons and putting them to work, storing them, and just going through this wonderful virtual cycle. So if we can get to a situation where we can remove the world's fear of fission reactors, at least in the interim, then we can have abundant energy. Like, for instance, France, it's saturated with electricity. We can have abundant energy because we won't have to store the nuclear fuel right next to the reactor like you do in the fuel pools, the cooling pools in Fukushima. There will be a method to deal with it, and you don't necessarily have to have a massive reactor, because you could have a really small advanced one and it could use thorium and so on. So there's all kinds of ways to move forward where you can help people's problems with fission, which I've had for many years myself, but now I can see that there's a solution to this, so that there shouldn't be the accidents, because there won't be the proximity of those things. If there are accidents, they're going to be minimal, and they're not going to be much of a problem. They'd be like cleaning up an oil spill type thing. I mean, even on ground, this is not going to be a million-year problem or several million-year problem. And so once you've got abundant, carbon-free, completely carbon-free electricity, you can use the aluminium, water, air fuel cycle, and you have completely carbon-free electricity generation and motive force generation, and you're done. You're done. Safety is not part of the lingo. So, any new updates on the materials for effective shielding for strange radiation, e.g., how would boron nitride compare to multi-layer conductor insulator? I think boron nitride might actually generate heat. It might trap them. I think still the massive numbers of impedance changes, i.e. going from the fourth most conductive element, aluminium, to the polymer, i.e. a sheet of mylar, and multiple sheets, is probably the best way to do that with the understanding we have. And this is why I think it's important to maybe mass produce some strange radiation generating material like the eco fuel, and then test things where you have the boron Shishkin detector, the webcam that I developed concept, and the parabolic and radionuclide detector of Alexander Parkhomov, and see which materials. I would like to see a research program so that we can actually understand what is the right materials to use to shield ourselves, so that we can make reactors that are safe. We found ways to shield ourselves against X-rays. We found we go to have an X-ray on our teeth or on our broken arm or whatever, and the guy stands behind a lead shield. Done. They know they're not going to get the X-rays. So you want to have that level of confidence that if you're behind this, you're not going to have a problem. And so I think we should just have a program. But this is why I appeal to Suhas Ralkar to work with us, use his expertise to really deliver something of value. There's multiple solutions to the energy coming out. There's going to be multiple solutions to various aspects of nuclear synthesis and so forth. So I think what he has is a technology that we could develop, and it's got a lot of hard work to go from there to having the devices to test the fuel for activity and the shielding aspects of stuff. But this kind of information is going to be really, really important and valuable to understand as we move into the next stages of this technology's deliverable. Yeah, so John can use, so where John was previously, not where he is now, but he had one of his ray guns up and running, and within a certain field around it, a certain distance around it, it had the lowest. This is, I haven't validated this. This is what has been said by him, but I what I found about John is he's pathologically honest. It's everything he says eventually checks out. what is difficult for most people is they find it so unbelievable. So it's automatically discarded. But anyway, the point is, he said that the environment for quite some distance was the lowest radiation level. So that means that the radon that's in the environment was effectively being deactivated, or at least, how should we put this? Maybe it can't express its radioactive decay. Anyway, for whatever reason, John has a very good sponsor right now, and I would like to see that around Fukushima, there are a number of his ray guns set up so that the actual working environment for the cleanup crew is a lower toxicity, and for the animals and stuff in the immediate vicinity. This is something that's really useful in that instance. I don't know how useful it is in Kerala. I mean, they did lots of studies in Kerala, which, as I said before, is the highest endemic, like it's everywhere. They have to live with it every single day of natural background radiation in the entire world. And there's been a number of studies done on the fishermen who are literally walking around in this thorium sand, and they have no higher cancer rates than general people in the West. So or people that are not under that onslaught of background radiation. So it might be that their constitutions, their bacteria or whatever, have learned a way to deal with that. I think it's the really nasty stuff. I mean, there's different levels of, okay, so alpha radiation is not going to get through your skin much, but if you're depends on the energy, of course, but beta particles and X-rays, these things are a little bit nastier, and you can get some really nasty things. And given the fact that if you go and look at the Shishkin presentation, they have actually observed strange radiation, ACA string vortex solitons, ACA condensed solitons of cold neutrinos being emitted to be coming from cesium-137. So there's plenty of cesium-137 at Fukushima, and so you could be exposing yourself to that. And it might be that those kind of like unnatural radiations, because there's not normally a lot of cesium-137 that you're exposed to. The thorium's not so bad, if you know what I mean. And then most of the lanthanides do alpha decays, and so it's not really, that monazite isn't so much of a problem as these really nasty fission products that come out of uranium fission that we seem to potentially have a solution for. Yeah, so Mr. Conscious Energies, yes, I feel that he has got the solution for the broad scale environmental radiation remediation, or protection from radiation in the local environment. And like I say, it's really valuable in somewhere like Fukushima, where you have workers that need to be there, and there is cesium-137, there is strontium-90, there is that really nasty 300,000 year isotope of chlorine, and so on. That are all beta emitters, and most of these things like tritium, they can all become part of your body, and so you really want that to be a low exposure level. Okay. Okay, so I'm repeating a previous question I submitted, Bob, but what exactly was said at the conference about the Sapphire Project tech becoming classified in the United States? Okay, so as I understand it, and this is just my hearsay, I think they're worried that if they try and push the energy angle, that might be a problem. I think that the radiation remediation angle might be less of a problem. The reality is, I genuinely believe that Matt's has some insight that Rossi may open up his technology. I actually believe that I said at the conference that when I sat in a barge in the Thames in the early 2000s, talking to a bunch of guys, some of which claimed to be of the military type, about another technology which had extreme significance. They said that basically, if you try and patent this, it's not going to happen, and the military will just use it anyway, and you won't benefit from it. So that was a bit of an eye opener. But since then, I've seen multiple people in multiple countries tell sob stories about how they've been told to unthink what they invented and learn to accept that they need to not talk about it. Let's put it like that. And so I genuinely believe that if you create a slightly better vacuum cleaner, if you create a slightly better mop, if you create a slightly better way to make a faster communication, you know, no one's going to want to classify that. But this technology has such a level of impact potential that you simply have and can only make it open. And I think that comes down to the spiritual context of it. You only have to look at the example of Kenneth Shoulders. He knew the importance of this technology. He knew what it could do. He's kind of like that kind of Tesla character that could look 100 years into the future and look what the implications are. A lot of people, they think that the version of the technology they're looking at now is as good as it's going to get. And then it's only in 20 years' time when they look back on what they had and they think they're just a freaking idiot. Just one thing I'll say, look at the progression of data storage. And maybe if you're the age I was, that the first time you got a 640 kilobyte drive that I can hold in my hand and I can store things on it like GIF images, or not even GIF images, like bitmaps and stuff. And it's amazing. And I can retrieve that image, and like it's such a thin, it's much smaller than a piece of like 20 sheets of paper, you know. And now we're looking at terabytes in your phone. So, you know, this is so what Shoulders realized is he wanted to patent this, but only so that the technology could be made public and not so it could be classified. But he knew it would be made classified because he was, you know, been through the mill a few times. And so he wrote the book, which you can find now, called EV, A Tale of Discovery, about his work from 1982 to 1987, which describes how he went through the process of learning about this phenomena. And he self-published this book and sent it out to a bunch of people, and then he sent off his patents, and they were all, you know, sworn to not disclose it to anyone, so that he could still patent it, so it's not in the public realm. And then they came back and said, look, you know, this is strategic importance. We need to patent this. We need to stop this patent from being published. We can't talk about it. Blah blah blah. They said, well, I'm very sorry, but I've basically described exactly how to do this and how I came to discover it. And I put it in a book and I've sent it to a load of people. And they said, well, we need their names and addresses. And it was like, oh, dog ate my homework. Or computer says no, the hard drive failed, or I don't know. But anyway, he lost the addresses, this is the story. And so they had to let the patents be published, because at least it was an American patent, I guess. You know, it wasn't like someone else patented it in a different country. They had to put their flag in the moon type thing, at the very least. And so, you know, this is one strategy, but you know, not everyone is as really forward-thinking as, I mean, that just shows how much he could see what the technology could do in the future by planning his release of the information in a way that it couldn't be locked up. And you know, that was a real masterful stroke on his part. And of course, those patents are all now expired, so you can use them. So what are some of the timelines on lead reactors for commercial heat system production? I would like to provide high performance generators. You know what? So would everyone, but I can tell you, the closer you get to a sensible COP, the more likely you are to have your reactor fail. Alexander Parkhomov, I don't think people appreciate just quite what he achieved with that reactor that ran for 225 days, producing a very large amount of COP in a very small device. That is really a seminal moment. But when you take the reactor apart, you look at it, it's falling apart. I mean, one would expect that if their gas boiler is running, it's going to be running for a very, very long time. You know, they expect to get a 10-year life out of their gas boiler, their furnace, as you call it in the States. And so, you know, these things, 225 days is the best that anyone's done type thing that is willing to share 99% of the detail. So it's some way off, and this is why I'm advocating for looking at using this nucleon reorganization destruction, but leading in a gentler way to stable isotopes, to deal with the technology that is going to be doubled in times and in capacity, whether we like it or not, because the contract's already signed between now and 2040, and that is normal fission reactions. And focus on energy delivery system, and say the aluminium, water, air, drivetrain, electricity production systems, because you're working with the technology, what it wants to do, and by using that aspect of it over many years, and learning how to deal with the emissions from it, and learning how to deal with the containment of that, we're going to get to a point where we know already what we need to do before the transition to straight Lena. So I think the focus should be on fixing the energy problem in a zero carbon way for the entire needs of humanity, and dealing with the outlying and remaining safety issues with the technologies we already have. And then that would allow us to segue through to the use of the technology directly, when we can understand and tame it better. So okay, totally agree. Never try to patent, go to research disclosure if you want some licensable IP, which is still, yeah, it's really sad with technical IP like this, which generally takes a lot more effort than software. That, you know, you can write a piece of software code and it's immediately protected, you know. And you can start suing the person that copies it, and strictly speaking, they can just copy it or they can just infer it, but it is a shame. But you know, I talked about everyone recognizes Tesla was a genius, but he patented a lot of things, and in a way, we're suffering right today because those technologies were taken and classified. If he'd just laid it all out, we'd be way ahead of where we were, and he would have the credit for it. And so I implored the people at the conference that there's this concept in money called the velocity of money. You know, so I've done quite a bit of I've done my sentence in the City of London. Let's put it like that. And there's a thing like, if you have $1,000 bill to pay, and you don't pay that for 3 months, you know, you manage to say, oh yeah, the check's in post. Oh yeah, maybe that one got eaten or got in that hurricane or whatever, you know, and you keep not paying that $1,000. Then the person that's receiving it reduces their spending and can't pay their bill of $1,000. But if you paid like the $1,000 immediately, and they paid it immediately, and they paid it immediately, you know, with the banking system, for instance, in Europe, being able to do a transaction in seconds, you know, within a couple of hours, that $1,000 could pay 10,000 $1,000 bills. It's still the $1,000. It's just moving through the system, and this is the velocity of money. And so I tried to get across the concept of velocity of ideas, or velocity of IP, or velocity of intellectual capacity. You know, by constraining your idea, by spending 3, 4, 5, 6, 7, 8, 9, 10. I mean, there are literally people in the Lena field that are still fighting for their patents 20 years on, or 10, 15 years on. You know, so it hasn't even got to the point of anyone believing it should be published. So it's already had a 15-year delay. So the velocity of that idea is incredibly lethargic. It's like impossibly slow. The velocity of the idea of most of the important Tesla patents is basically zero for 100 years, and we're not even sure it won't be extended beyond that. You know, so it's foolish. If we really want for for humanity, we have to appeal to those that ever want to see this in fruition, whoever want to see the value for anyone yielded from the intellect or the inspiration that they got gifted from the Akashic record. You know, they need to get the idea out there. That kind of information needs to be free. And by having a system where you can kind of pretend you're going to get some money, you're going to be famous, you're going to be blah, 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 there's always these traps that means that the velocity of ideas can be set to zero. And so, you know, I said to the Sapphire team, you know, there is a way, an approach. What you can do is you can do a provisional patent. Firstly, you need to tell a bunch of people how to do it exactly, and make sure you get the kind of protection that was cleverly devised by Kenneth Shoulders. And then you can provide a provisional patent, and then you can actually tweak the provisional patent for a period of time, and that gives you a certain window in which you can work. And then what you do is you go out to potential competitors or potential people that might want the technology that you believe you can deliver, and you say, look, I'll tell you everything you need to know. You work with me, you support us, we work together. You bring your expertise in manufacturing, you bring your expertise in electronics, you bring your expertise in control or distribution or whatever. We form a consortium, and the information is out there, but there may never be the intention to patent it. What you're doing is, within that small window of the provisional patent, you're getting as many people signed up to make this happen. So it's because in the case of them, Montgomery Childs said, look, we've already taken $15 million on this, so we basically have to make a return. So they've already gone down that road. So what I was trying to suggest is maybe a middle road. For people who've got the idea and want to see it out there, just get it out there. Because so many times the same thing is being rediscovered. I'm so happy that I went to this conference, because the idea that we can resurrect from the dead the last best version of the Brown's gas generator and put the information out in a form that anyone can construct, you know, right the way down to the engineering diagrams, and knowing precisely which elements were used and all of their relative distances and stuff. The end of that is just wonderful. But you know, there was one of the presenters there, I forget his name now, but he was talking about going to New Zealand and meeting John Bedini, and he was standing there. He did this video in the 80s or whatever it was, and there's the Bedini motor there, and it's sitting there at his feet. And now he wants to find out where it is, because he has these rumors that one bit went over here, another bit went over here, and you know, could he construct it? Could he get it working? I don't know. But here we have an opportunity where there's a guy that has operated this device. He did work with Yul Brown. The device exists. It needs some love and attention, but it's all there, and it's the end of the road. So it's something that we absolutely have to take advantage of, and then we can test for its ability to do nuclear transmutation, test for its ability to stimulate the product or seed active material for lead reactors and so forth. So velocity of ideas. Okay, so Sunsaver talks about magnetic motors. I would love to see what the performance is. I think so if I look, I already talked about the fact that the Robert Reich and Roberto, they gave their presentation, and I have the figures on here. Where is it? I think I'm going to have to call it a night in a little bit. Yeah, so they set up Gaia, and they've been running for about 8 years. And what they did is they had this guy that had this kinetic motor, and they put out a very small little marketing clip. And you know what? They had 39,300 pre-orders, which totaled $618.5 million pledged. And then the guy decided, I don't want to make units for homes. I want to do it for industrial units. And therefore, that was the end of that. So they knew the potential there. So they've been around the world and they've seen a lot of stuff. And they did go and see the Yildiz motor, and they set up a test. And they're in their test, it lasted the longest any Yildiz motor had ever run for. And it was meant to run for 24 hours or 48 hours or something, or 6 days. I don't know what it was. It was a lot longer than it did run for. It ran for 6 hours and 43 minutes. And that is the record, as far as they know, for any magnetic motor on Earth to run for before failure. And some small part in there failed, and it was just a shame. They actually went and spent 200 days in South Korea working with the Infinity South team. And when they did that demonstration on that lake out in the open air, it lasted for 5 hours. That's not even beating Yildiz. They still have a relationship, an ongoing relationship, advancing work with Yildiz. The Magmov 2000 or whatever it is that I kind of like, I could see it was a load of rubbish, or at least I didn't know, but what he was saying had no sort of engineering logic nature in my head. And I asked him the most basic question in the world in Graz a couple of years ago. The guy who runs this other sort of technology vetting organization, where is his name? The English guy, John Cliss. He actually got a license for this in the UK, and he got a bunch of bits. It never worked. The Magmov does not work at all. And all his contact details have now disappeared. And, you know, for me, it's heartbreaking because I keep seeing these people contacting the MFMP's video, where it's the whole purpose of the video is it's a warning. And people are contacting because they have nowhere else to turn, and they're saying, I sent to check off, blah, 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 blah. And, you know, so I would like, and the only one that hasn't been tested by either of these two parties that were at the conference was the Earth engine. And to the better of my knowledge, that hasn't run for longer. Maybe it has, maybe someone can correct me on this, but as it stands now, the longest any magnetic motor has run for in the world by any party producing any significant torque is the Yildiz motor. Works for 6 hours and 43 minutes. Well, you have the Parkhomov reactor work for 225 days. Yeah, you have to find a mechanism to help the inventor, because they do have bills. I can tell you the sacrifice that I've made just trying to test technologies for 8 years, from $170 an hour, being able to buy anything I wanted and go anywhere I wanted, to earning nothing for years. You know, it takes a certain kind of insanity, and I'm qualified. Inventors often sacrifice so much, and they get so much flack from their family for not going and taking a proper job, that they do want a big payday. And there are people out there that do have funds, and thankfully some of those people have supported our testing over the years. But you know, it takes a lot to build up trust, and sometimes you know, an inventor hasn't got the time to invest in a large community of people to build their trust. And so they get left with two options: try and cash in or give it away. and that is the reality. I know my brother has given several technologies away. He's a full-time inventor. He's effectively given them away. Um, yeah, I mean, from my point of view, very acutely with, for instance, in the case of John Hutchison, he's happy to give it away. He's got a good sponsor right now, and we just need to get that technology into the place where it can do the most best work. In the case of, in the case of our common goals right now, which is to fix radiation, particularly in places like Fukushima. In the case of Suhas Ralkar, I really hope that he can see that his window is now, and you know, if he can help us define what is the way to monitor and shield strange radiation, and at the same time give a real tool for fixing the Fukushima cause and enemy tech atoll. I hope that he sees that that would be his greatest contribution to humanity, because the window on him being able to do that is closing. And he has an entire lifetimes of expertise thinking through what is the right way to deal with ultrasonics. And you know, you can't look in a textbook to get the knowledge that he has. And so I really hope that he sees the importance of what he can deliver. But it needs for him to want to work and allow that to happen. So I hope that does happen. Okay, so never tried to patent disclosure open source technology. So just trying to find. Okay, any questions? To the Stars Academy is crowdfunding, but keeping the cash for themselves. You know what? At some point, you've got to ask for the honesty. These are very difficult things to say, you know, what this technology can do. And, you know, having been through the, should I say it, should I not, and deciding to say what is the obvious truth, I knew what I would receive in terms of pushback. When you've had people in your face and for quite an extensive period of time telling you to stop doing stuff, and it's like, well, you're not paying me. What are you going to do? Sag me? It's like, who are you? What value do you think you have in telling me to not do what I'm doing? Why do you feel it necessary to say that to me? You're like, who are you to say this? You know, there is nearly unlimited funds to maintain a certain understanding of what's possible. And, you know, there's few people out there that have the capability to push this through. So we need to help those ones that can. And the Sapphire team themselves will almost certainly be trying to find their way through this forest. And to the Stars Academy, I think they're also trying to find their way through, but it's excruciatingly slow. Bob, are there any details that you can remember from the Sapphire Project presentation? I can remember a hell of a lot of it, but to be honest, you can pay a small streaming fee and go and watch it yourself. Actually, there's not a lot in there that wasn't already said. I think and in fact, having met Montgomery Childs and the SEM guy at ICCF 21, and having literally nothing come from them, and nearly nothing coming from them this time, I've resigned myself to the fact that it might just be a one-way street. But from my point of view, if they're going to develop a technology they need to come to terms. I mean, what they did have actually is they actually showed a concept reactor for a device to produce heat commercially, and I thought that's not going to work. If it does, well done. If it does, well done. Good for you. But you've already seen the core meltdown, and you might be able to control an Evo 99 times out of 100. Then there's a certain flux of solar wind, or the moon. There's this lunar eclipse, and then it completely melts your reactor down, and you have no explanation for it. So I think we need to understand the underlying thing. This is for me why working with its ability to mash up nucleons and fix radioactive waste without trying to necessarily at this stage get all the excess heat in the world out of it, allow it to be an enabler to a carbon-free future, and to understand the technology better. For me, I think is seeing everything I've seen and seeing all these different experiments come to failure through falling apart, and listening to those words and taking them on board that Ken Shoulders said in MIT in 2006, where if you want to create excess heat from this thing, you're going to have your reactor fail on you, but you can generate electricity, and he's described how to do that. So you know, I think maybe that's where, if Rossi has something, maybe that's where he's at. He's suspending his exotic vacuum object structure. Now, when I say an exotic vacuum object, he's not necessarily a toroid. You know, the toroid, as Bogdanovich has shown, can form a kind of like crystal-like structure, and then you can imagine that if they're fractal and they go out, it ends up just looking like a ball. And then they can have their layers, because you've got the light, but not enough to merge type thing. So, but you need to keep it separate, and as I've said from the beginning of my understanding at this stage, was you need to make and break. You need to make and break. You need to make and break. If you make and make and make and make and make and make and make, it will destroy your reactor. It will destroy your reactor. You have to give and take. You have to give and take. Okay. Yeah, Gaia are trying to do something, but again, just like John Kliss and his organization, they are facing the reality that there's a lot of people out there that are deluding themselves. And that's just the truth of it. The problem is a lot of people don't have this access to the velocity of ideas, the velocity of information. They're all kind of working off these fuzzy drawings and what someone said on a forum, and that's a real shame. So from my point of view, Amaza really has something. He really does. And it's got aspects which are similar to Brown's gas, and it looks like we're going to get this Brown's gas generator. So it's been in a time hole for 20 years or whatever it is. Let's resurrect that knowledge, get it precisely out there, so that people can move on from that. We as humanity can move on from that technology. One thing that they repeated, actually, and I meant to do a whole presentation on this before this conference, but I will try and do it this week, and how it fits into everything. But they talked about MIT, and this is not their invention. But MIT say that if they take atomic hydrogen, they put it on uranium, it stabilizes the material very rapidly. And you know, this is known. And I will say this now, when I was told about the reasons why Amasa didn't want to ship things to America, it's because I have to be aware and I'm concerned about the hidden group, because this is about atomic hydrogen. And I go, okay, all right, atomic hydrogen. But you know, Piantelli is producing atomic hydrogen, and that's going in, and that's the principle of his patent. And it's not the first. And so I'm going to walk through people those aspects of this, and the history and how it relates to Brown's gas and to things in the past. Yes, I think we should do a three-way session with John. Thank you, Conscious Energies. Yes, I think that would be a great idea. I love the guy. I really do. He's a beautiful soul. And by the way, John wants everything to be open. And sadly, because of going to the ICCF and be doing the Space Earth Human book this year and going to visit Mars and analyzing that, I haven't got out what I wanted to do on the analysis of John Hutchison's materials. But again, that is top priority for me, and I think it's going to blow people's minds. Shannon, the fact that you're even here means you're part of the team. The single most important thing I think anyone can do right now is to educate themselves with facts that are coherent and consistent, and go to the resources like Adamenko, like Shoulders, like Leclerc, like Matsumoto, Takaaki Matsumoto. These people who've clearly defined A, B, and C, and D, and Hutchison's work, and then look at what Sapphire are seeing now. Look at what we've observed and shown with various other technologies in recent years, and you will start to see how should we put this? It's almost like a face coming out of the fog. All it is fog, and then you suddenly realize you're seeing something, and then you're seeing something that's got two arms and a leg, and now you're seeing that's what you've been looking for. And to get understand those references, and hopefully get the Space Earth Human book when it's published, and understand it's going to be a little bit difficult read in places for some people, but the information in there is very important for this field, I believe. Yeah, 21. There was a comment in here about John being booted off YouTube. I was there through that whole process, trying to work through with him. What happened was, oh, hold on, I got someone here. Oh, I'm too loud apparently. Probably. John had 4,700 videos on YouTube, and they basically struck him off, saying that some of them were misnamed, and he tried to rename them and so on, but it was basically not appeal. In my view, he was starting to talk about some people, both in replies to things that I'd said and we had done together, and he was crossing a line, and some power was exercised. And you know, I've seen enough now. I've had people in my faces telling me to stop saying things. I know that you know, that's the reality. I will encourage people to use 4K Downloader. It's a very affordable app, and if they get a 1 terabyte drive, I encourage anyone out there to who's got a fast internet connection to download this video and also the entire MFMP channel as a service without them knowing it. So certain channels I do that anyway, because I've seen too much being memory hold right now, and you know, sometimes I might not be in a position at some point to tell you what I've told you in this video and in some of the more recent videos in the last couple of years. So I would encourage you not to let this be memory hold. Okay. Yeah, Mars is amazing. It's true. And I really hope that we do see that press release, which I feel may be coming before Christmas. And I feel happy to have been able to play some part in these things happening. Okay. So it's gone past 2 o'clock here. I'm going to run through the comments, but if anyone's got any specific questions, you've got a small window here before I'm going to need to sleep. I'm a bit exhausted after this weekend. I didn't really get a chance to do what I wanted to do on this, so which is go through day 2 presentations and what comes out of that. So I might actually do that in another live stream in the coming days. Give us an example of someone who told you to stop. They are known in the community, and I'll give you the one example. A guy called ABD doxed me, and I have thanked him profusely at ICCF 21. I sat down with him for one dinner in the evening, or certainly a few drinks, and thanked him at length for trying to destroy my character, you know, my reputation, and trying to put my family at risk. Because had he not done that, I would not have had the opportunity to meet John Hutchison, and you would not have had the opportunity to see and to start to see really what John Hutchison actually achieved, and how the technology may have actually been working at the core level. So I really think that sometimes, you know, when someone tries to stop you doing something, they give you the tools to be able to actually do it. And this is why, for me now, and for many years now, this has been a, how should we say this, it's a spiritual journey. I don't even have a choice. I just have to do this, because every time I have my conviction waning or lose a little bit of my conviction, something comes along and says, nope, you've got to be doing this. Yeah, you know, some people are just misguided, and sometimes they say things, maybe they're trying to protect something, maybe they feel they're doing you a favor, maybe they think they're doing a community a favor. But it went from a couple of years ago from many people in the community saying, Bob, what are you talking about this nonsense for, blah, 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 to actual people, really seriously high up people in this community coming up to me and saying, damn you, you got me started on this, you got me started that, now I have to think about it. So, you know, if the truth will always be the truth. That's how it is. And, you know, I've said I thought I knew how things worked in the past, but, you know, I thought I could run before I could. I thought I could cycle a bike before I could, you know, and I still fell over, you know, even after I could cycle. You make your mistakes on the journey towards, you know, better understanding, let's put it like that. And, you know, just because you can cook an omelette now didn't mean that when you couldn't cook an omelette, you're not valid for cooking omelettes, if you know what I mean. So when people, you have to give people the opportunity to assess what you're saying is the truth or not. And you should speak up. If you think you understand something, get it out there, because no one's going to care if you're really wrong. But if you're right, you will have helped move things forward, that velocity of ideas, that velocity of information. Please use Fusion 360 instead of SolidWorks. Fusion 360 is free to install for non-commercial product. Great for, yeah, okay, that's great idea, Metal Gear Mark III. This is, obviously, we would like that to be open source. I was suggesting SolidWorks because I know someone who is an expert in SolidWorks and could do that work. Perhaps Fusion 360 can import a SolidWorks file, but you know, what I was hoping to do is to if you do the Kickstarter, it would be so that, you know, it would be turnkey. If someone wanted to produce these things in their local market, they could go to the local metal sheet bender, SolidWorks file, they could give them the PCB layout and so on, and the various contractors in their local market can make the devices, so they could synthesize these things using the pipelines that are already there. So you know, this is very early stages. We only got the understanding that we received this generator on Friday night. So and I've been at the conference or traveling for most of the rest of the time. So it's early days. So I will, you know, maybe I'll do some live chats and we can discuss what's the best way to put this out. I think that there will be a huge interest in this. Once the end of Yul Brown's expertise and all of the final research embodiment into this device is then saved for future, people can then look to augment it and improve it. Maybe, you know, I had one idea in my head, you just get a small vibrator and put it on top, you know. Just one thing, you just, whatever the electrolysis plates are, shake them a bit, you know, and there will be 1,000,001 ideas. But the problem is, as we learned with our first replication attempt, is we failed because we changed the borosilicate glass in the Celani cell for a quartz, because Celani said he was going to do that next, so we thought we'd leapfrog him. But we failed. We didn't see any excess heat, so we went back to the exact replication of what he had, and it worked. So let's do the tests with the reconditioned Brown's gas generator, see what it can do. Does it do nuclear mediation? Does it do transmutation? Does it weld these things as he said, and capture all those things on very high quality media? So these things are now beyond dispute and beyond reproach, and then gift that technology out there. And now that it's not, has no patent protection or anything, and then people can build on that as something that works. When you can make it better, there will be the opportunity to make it better, but you're starting with something that works. Peter Middleton commented about the anti-EVA brigade, and you know what? Having gone to the Gratz conference and having gone to this conference now, I can say there is great value in people in the low energy nuclear reaction field considering speaking at other energy conferences. Firstly, the Graz conference had better attendance than any LENA conference. And the crazy thing, and I actually went there because Francesco Celani was meant to be speaking, but then he couldn't make it because of health problems. But basically, nothing worked at that conference. But there were a lot of people that are very, very interested in this field. As I say to people now, you know, there are transmutations occurring in your body every single second of every single day. The potassium 40 is going to calcium 40. That is a primordial isotope. It's been there since the dawn of the time. There is carbon 14. It's going to nitrogen 14. It's the principle of carbon dating. That's why they know how old you died when you died and you got buried. And this is not primordial. This is synthesized by cosmic rays interacting with every single second of every day. Transmutation is occurring. So we don't have to debate transmutation. It's a real thing. Transmutation also occurs in atomic clocks. It also occurs in nuclear reactors. So, you know, this is a reality. It's just people got stupid, you know, they didn't think around the problem, but the clues were all there. Many of the clues were laid down by Tesla, but most of the best research has been done by the Russians. So, you know, okay. Yeah, nucleon exchange is much better than fusion. Yeah, because fusion has the problem with creating hot. Well, there are fusions which are aneutronic. Ideally, you want fusions or nucleon exchanges, but the fusions you want to be aneutronic. You know, if you had a series of good questions for the Sapphire team, I know they're kind of basically in marketing mode now. They're trying to see, well, we've got this thing, it does X, Y, and Z. We can repeat things. How can we make this commercial? They're looking for ways to find, you know, what that commercial angle is. So I would implore them to actually go to your channel, because it's not always obvious where you find the thing that you're looking for. I mean, who would have thought that I would go to this conference and be in a position to potentially have access to one of the only Brown's gas generators that exists in the West. Original end of research device. You know, you just don't know what will happen, and you won't know if you don't try. Do you think they are willing to engage in discussions about their technology? They are. Certainly, I sat across the table from Michael Claridge for the best part of an hour, and he approached me, but I did lay down the gauntlet because I'm genuinely concerned that they are now observing low energy nuclear reactions, and these things, I mean, whilst it's a surprise to them and they think it's woo, what they're observing are exactly the same things that have been observed by many researchers over many years. So I would love to see them at the next ICCF. I mean, really, they should be there. I think they have to be there. But you know, I think in part because the strength of the electric universe community is actually a very large community. They have this exposure that the LENA field never got. You know, they already had this captive audience, and they need to capitalize on that. They really do. but they need to reach out to other communities and find, you know, more people so that it's seeded into the consciousness of more people. Okay, it's nearly 2:30 in the morning here, so guys, I'm gonna say goodnight. Like I say, there's much of what happened over the weekend that I've got notes here which I haven't been able to say, so I'm going to have to do another live stream. But thank you very much for your time, and I kind of like this format. Thanks, Ron. I like the fact that I can get to see your comments, and I think it's better to be in an open format like this. So thank you, and have a great day or night or morning from wherever you are. And I shall see you in the coming days. Look out for my coming presentation on atomic hydrogen. And I'm hoping to publish in the next week or so the transmutation data from the cesium chloride. It's absolutely stunning. From the test that we did in a Masa vibrator, and also start rolling out the SEMs and EDSs from the metal treatments in that end of the beginning of the end, or end of the beginning video, end of the beginning video, because and just even on the titanium samples, there's bits that are much more valuable for you guys to come to terms with, which I haven't had the time to package up yet. So I'm really looking forward to hear what you guys think about that, and see what the community does with the information. So thank you very much, and from me here, it's good night. This is Bob Grenier signing out for the Martin Fleischmann Memorial Project.